Hello everyone, welcome back to Coding with Mock, and in this last video in the Git introduction series, we'll be looking at Git Remote Repositories. Now, what are Git Remote Repositories? Remote repositories are in fact the way in which we will be enabled to work with others or to collaborate with our colleagues. Okay, now I will be showing you how to work with a website like GitHub, but know that working with GitHub is actually the same as working with Bitbucket or with a privately hosted GitLab. In essence, the website will be different, but working from the command line, there will be no difference. Well, apart from the URL, that will be different, but that's the only thing that will be different. Okay, so all the commands will be the same using either of those websites. And then lastly, I will be showing you how to collaborate directly with a colleague, because Git is not a centralized version control system as we are using it now, or will be using it now using GitHub, but it's a distributed version control system. So if you really want to, you can work directly with your colleagues without the need of a centralized system like GitHub. That being said, there's nothing wrong with using a system like GitHub, okay? Just to make that clear. Okay, now to start out with, I already logged into my account on GitHub. And to start with, I need to create, or I need to tell GitHub, and this will be the same on all the other platforms, you will need to tell GitHub that we are going to create a repository, but we will not be initializing like we did in the first video about Git. It's not a Git init, but it's telling Git or preparing Git to accept our files. Okay, so let's create this repository and let's give it a name, Git demo. It's available, that's nice. I'm going to keep it private. Now, this step here, if you have already, like it's saying here, if you already have a repository, like we have, make sure that this is not ticked. Leave this empty, okay? Do not add a git ignore, do not add a license. That's really important that you do not do any of these things. The reason for that is if you do any of these steps, or if you tick any of these boxes, it will create a repository on GitHub, which means that your repository on GitHub will have its own history. Now, one of the things about Git is that it will never merge two repositories that have a different history. And with that I mean the first commit will have a certain hash code, and that hash code is compared every time that you will be uploading code to this repository or uploading to another remote repository. They will compare that first hash code. Well, it's not the hash code, but just for the sake of simplicity, they are comparing their histories, and if those histories are not the same, Git will refuse to merge those two repositories. So for that reason, leave this empty so that your repository, or actually your project on GitHub, is empty and is able to receive any repository that you want. Okay? Now let's create the repository. I'm just checking that everything is empty. I'm creating the repository. And now the important bit is here. This is the URL or the location of your Git repository. Okay, now let's just copy this over, and I'll show you how to link your existing local repository to the repository on GitHub. Okay, now to start off with, I'm going to check that my repository is fine and that I'm on a clean working tree. Okay, so that's fine. Now I want to add a remote repository to my local repository. For that, I'm going to use the git remote command, git remote, and then I'm going to tell it I'm going to add a remote repository. Now, to start your, in addition to just telling it that you want to add a remote repository, I also have to give Git an alias for this remote repository. Now, I'll go into the naming of our remote repositories later, but we will be calling our first remote repository origin, right? Now I'll go into the alias origin in a few seconds, but just know this is an alias. That's the important part here. An alias, it's just a name that I'm giving my remote repository. It's not an alias for my local repository, but it's a name for my remote repository. And then I have to give it also the location of my remote repository, which is my URL that I copied from GitHub. Okay. Okay, now let's run this command. And as you can see, no output. That's fine for now. This means I didn't make a mistake or a typo in my command. So everything went well, but just to make sure to check, I will issue the git remote command again, but now with the -v or the -v flag. And this will show me all of the remote repositories attached to my local repository. Okay, and as you can see here, I have apparently 2 remote repositories, but with the same URL. I will not be explaining that what the difference is between those two. Just know that every time that you will add a remote repository, it will add 2 different 2 lines within its database. Okay, one for pushing, one for fetching, and we will see what pushing and fetching is in a minute. Okay, now so I have my origin, and that's how I will be calling my remote repository from now on in every command, because I do not want to be typing in all of this all of the time. That's why we create this alias, and it's called origin, and this is the URL. Nice. Okay, so that URL seems to be correct. That's all fine and dandy. Okay, now I want to share my code with my colleagues, or I want to share my code actually with my remote repository. And now the first time that you will be sharing your code with the remote repository, you will be doing a git push. And with a git push, we will be pushing our code up to the remote repository. Now, the first time that you will be doing this, you will also need to specify the remote repository's name. So that's what we're doing here. We're saying push our code to origin. And because origin is an alias, Git will, behind the scenes, will be replacing this origin with this URL. Okay. Now I also have to specify what I want to, or which branch I want to push. Now in my case, I want to push the master branch. Okay. Let's see. Now it's asking me for my username, and I'll just be adding. Go. And my password. And there we go. If you see all of this happening, enumerating, counting, delta compression, and so on, that means it's uploading your code to the server. Now you will notice also that this is happening. To HTTPS and then the URL, new branch, master, and then an arrow master. Branch master set up to track remote branch master from origin. Okay, what this means is that on the remote repository, which is in fact also a repository, that's something that you probably heard for the first time now, but that you will need to remember is that while I have my local repository here on my C drive, or in my temp folder on my C drive, the repository that I created and now uploaded to on GitHub is not the same repository. It will contain the same data as my repository, but it's a different repository. Okay? So we're basically pushing everything to that remote repository. Now, because that remote repository on GitHub is also a repository, it has all the same features as I have on my local repository, being that it can contain branches, it will contain commits, and it has, in fact, also a staging area. Okay, so what basically happened here is that my master branch, or my local master branch, has been connected. Well, not in fact connected, but I made a reference within my local repository that my local master branch is the same as the remote master branch. In fact, I'm not really saying that they're the same, but that my Git on my computer should treat them the same. So if I commit on my master branch and then push my code, it will push that code to the master branch. Okay, that's how you have to look at it. There are two separate quote unquote branches, and I'll show that as well in a second. But they are treated the same. And all the commits on my master branch will be shown on GitHub as being on the master branch. Okay, so let's see what happens here if I refresh my page after that I committed. You'll see, okay, I don't need that. You'll see that I have 12 commits and I have one branch. Now you might remember from one of our previous videos that I created another branch, the feature one branch, but that's not reflected here. If we go into our branches here, I only have the master branch. And that's something I'll show you in a second as well. Now I have 12 commits here, and let's have a look. And you might remember the commit, all of the commits that I did a few days ago, or well, in a few videos ago. Commit 1, commit 2, and 4. My merge with the feature branch, feature commit 2, and so on and so on. Right? So if we do the git log here, you will also see that I have the same commits here as I now have on my remote repository. Cool. Now, I said that we had to look at our remote branch or our remote master branch as being a different branch. And let's have a look at that. If I issue the command git branch with a -a or -a option or the -a flag, it will show me all of the branches that my local repository knows. Namely, I still have my feature branch. I also have my master branch, and I'm apparently on the master branch, but look, it added another branch, namely remote, a remote branch on origin, and it's called master there. So those are two different branches. Okay, so that's one thing I want you to remember really vividly and keep that in your mind at all times, is that if you're working with a remote repository, that's a different repository from yours. It will contain the same data, and we will be uploading to that remote repository, but it's a different repository. Okay? Keep that in mind. Okay, now, so what we've seen now is that we can push to that remote repository. We can add our remote repository as well by using the git remote add and git push command to push our code to a remote repository. Okay, now the next thing I will be showing you is how to well, work with this repository if we, what to do next if we, let's say, continue our work. Now we've set up a link between our local repository and the remote repository. Let's just simulate that we're doing some work. So let's open up the test.txt and let's do some work. Git. And we'll still be working on the master branch. So do master branch commit, and I had 12. So let's do this commit 14. There we go. Just save it. Easy enough. Okay. Git status. Okay. Now my test file has been modified. And now the first thing I have to do is I have to commit this work locally again. Okay, so I'm adding my file to the staging area. I am committing. Just add a commit message. Commit number 14. I think it's number 14. I'm not really sure. Okay, so now I've committed. My working tree is clean, but now you can see your branch is ahead of origin master by 1 commit. And now I have to push my code, because if I look here, I'm still at add git ignore. That's the last thing I did. Namely that if you commit locally, it's not automatically pushed. That's something that you will need to do manually. Okay, so now I need to issue the command git push, but it becomes a little bit easier now. I don't have to link my master branch to the remote master branch anymore. That's already been done. The only thing I need to do now is just git push and enter my credentials again. So let's go. There we go. And it's pushing. And if I now refresh my repository on the remote, you'll see my commit 14 shows up here. And I can check what happened here. This is a diff. This is the same diff that I showed you a few weeks ago, or a few videos ago. Namely, this is basically that git diff. You might remember this from our git diff demo that I gave you. This weird notation, right? Again, not really that important. The important bit is here. This is the difference between the previous commit and my current commit. Okay, so you can also look at the code just by going to the code tab here, and then I can open my files. Also a handy feature to have. Okay, anyway, so that's how to get your code to your remote repository. So either you, well, first you need to add your repository as a remote repository using the git remote add command. And then the first time you push your code using the push minus dash u origin master branch. So you're defining, I'll just type it out, just you want to push, but the first time you need to tell it, I'm pushing to the origin server and I want you to push the master branch, and it will then link up your local master branch with the remote master branch. And then all subsequent pushes, you can just use git push. Okay, so that's how you get your code to the cloud or to your remote server. or to a remote repository. Now, how do I get my code from? Let's say that my colleague wants my code. So the code that I uploaded to the server. Okay. Now, to do that, I'll just simulate that I don't have a remote a local repository yet. And I can do that really simply on this computer as well. I'm just going to do that in a separate directory. Okay, so what do I need to start off with? I need the URL. I also need access to that URL, but that's something I'll show you in a later in the video. But the first thing we need to do is, I have the URL now, I want to copy the remote repository onto my computer. Now the easiest way to do this is using the git clone command. And with cloning, you in essence create a copy of your remote repository. Now, what do I want to clone? I want to, no, I don't want to clone my, let's see, copy. And there we go. Git clone and then the location of your remote repository. Now, there's a little thing that we could add to this. Now, if I ran this command, and I'll just run this command and show you what happens. We're cloning into git demo. This means that the name of your repository will also be the name of the directory or the folder on your computer, right? Oh, tapped it. And there we go. Okay, so now I have a git demo directory here, and let's go into that directory. And you'll see I have a git ignore file, a feature file, new file, test file, and if I run a git log, you'll see that all of my commits are here as well. But if I run a git branch -a command, the only thing I'll see here is I have a master branch, I have this weird head which points to the origin master, and I have a remote origin master as well. Now, you can ignore this one for now. It's not really important. That's just something technical happening in the background. Your Git will work perfectly or will just work as is. You don't need to know about the head object, okay? That's for the advanced classes. Now, okay, let's simulate that my colleague did some work. And so, okay, colleague. Okay, so let's saved, added some, let's do a status. My file is updated. Okay, now let's just add it to the staging area. Okay, I'm committing. Colleague added some code. And now the only thing my colleague needs to do is git push. Now you might think that he needs to push to the origin and then link it up to the master, but that's already been taken care of. If the thing I can do here now is because I've cloned, it has already set up the link between the two master branches. And I can now just push. And let's push. Update credentials. I made a typo there. That should do it. And now I'm pushing as well. Nice. And so now if I check what happened here is, you see, my colleague added some code to the test file. And if I check here, this is also reflected in the file. Nice. I can also check the commits. You'll see that the commit history. Well, I've added code from the same computer, so it's going to say that it's me adding the code, so it doesn't really reflect me using two different repositories, but just trust me, these are two different repositories. Okay. So now you know how to push your code up to the remote repository. Now let's say that I'm going back to my original directory or my repository, and this is me now accessing my code. But if I do a git log, you'll see I'm still on commit 14. I haven't got that last commit from my colleague yet. Okay. Now I could clone the repository again, but that's not what I want to do. I just want to get everything from the server, right? Now what I need to do then is, or the easy way to do that is not push my code, because I'm not pushing my code to the server. And what I'm actually doing is what I want to do is I want to get the code or the commits from the server. And for that, we use the command pull. And the only thing I need to do is just do a git pull, enter. It's going to ask you for your credentials again. There we go. Enter my password. And now you see that it's getting stuff from the remote repository. It's fast forwarding. Don't worry about the fast forwarding. We'll get to that in a second. But let's see what happens now, or what happened to my repository. Is now I have that commit from my colleague. And if I open up test file, I have the code from my colleague. Nice. Okay, so now we know how to push and pull from a server. But that's the easy part. There's always a snag, okay? Now, this was the easy part. Let's go on to the hard part. And that's where our problems that we were having a few, let's say a few videos ago, when we were merging two different branches together, and there was work done on both branches in the same file. That's when we ran into problems. Now remember what I said about the remote branch, master branch, and our local master branch being two quote unquote different branches. And actually I didn't need to do the quote because they are different branches. Let's simulate that. Okay. In my temp folder, I'm going to open up the test.txt, and I'm going to add some code from person A. Okay, let's say that he wrote 2 lines of code. Okay, easy enough. I'm going to add and commit this code from person A. Okay. Now, before I push it to the server, okay, let's go into our Git demo folder, and this is my colleague's folder, and let's have him edit the same file. Now you see that the edits I made in the temp folder aren't reflected here because these are two different repositories. And let's say code from person B. And let's say that he wrote 2 lines of code as well. And let's add this and commit this. Okay, code from person B. Okay, so now we have 2 repositories, two the same repositories that were in both repositories the person or the programmer made or created some code in that repository. Now let's see what happens when they both try to push their code to the server. So I'm doing a git push from my git demo. And okay. So this has seemed to gone okay. Let's see on the server what happened here. Okay, so I have my code from person B. This is good. Okay, now let's go back to my first repository, or to person A, and let's have him push as well. Password. And now we see, ooh, red lines. My push was rejected, as you can see here. I have to do a fetch first. So failed to push, some refs too. Updates were rejected because the remote contains work that you do not have locally. This is usually because another repository pushing to the same reference. You may want to first integrate the remote changes, e.g., example I'm given, git pull before pushing again. So basically, when somebody else pushed before you, it will be your responsibility, because the remote repository can't do this for you. It will be your responsibility to add the code from your colleague to your local repository first, and then you can push. Okay, how do we do this? Well, I've shown you how to get the code from a remote repository by using the git pull command. Now I have to log in again. Password. But now, woohoo, you thought we were finished, but no. Now we get this. And you might remember this from that video I mentioned a few minutes ago about merging two different branches, but with changes in the same file. We got a merge conflict, and we have a merge conflict here as well, because our remote branch is a different branch from our local branch. They are set up to be copies of each other, but technically they are different branches. So when I pull, what actually happens is you're doing a merge between the remote branch and your local master branch. That's what's happening. So, and if we look at our test.txt file, you'll see, and this should be familiar to you, namely that I have a merge conflict, and with merge conflicts come merge conflict markers, namely the smaller than and then the head. Well, this is my master. This is the code from my master branch being the local master branch in the temp folder. And this is the code or that my colleague pushed to the server. And this is the, I think this is the hash code from that remote or that commit done into the remote, and 4db29c8, 4db29c8. Yeah. So that's the hash code for that last commit that my colleague made. Okay. So what do we do? What do we do now? Well, we fix the code. That's going to be our responsibility because we wanted to push secondly, and my colleague pushed first, so he got his code in on the remote repository. Now it's our responsibility to pull that code, fix that code, and then push that commit again. Okay, so let's say that we need all the code. Okay, so I just remove the markers. There we go. Now my code compiles again, quote unquote. I'm saving. Now, what do I need to do now is let's do a git status. I have a merge conflict, so I have to solve the merge conflict, which I did. I removed the markers, checked that my code was good and running. Now I have to add and commit before I push. So this is a merge commit. There we go. And now I can push. Look, Gmail, and my password. There we go. And now everything should be fine. Okay, so now I have code from person A, code from person B, and a merge commit. Okay, so that's how you pull and push from a server. Okay, so just to do a quick recap of what we've done up until now, if you want to work with a remote repository, to add a remote repository, we do git remote add, and then an alias for that remote repository, and then the URL that will set up a remote repository. So git remote -v will also show you that I have one remote repository here. Okay. Then if I want to get code from a remote repository, I use the pull command. If I want to copy my commits to the remote repository, I use the push command. And those are the commands that you will need to remember for now. Now, the thing that you also need to remember is that if you pull from your remote repository, in essence, you are merging your local repository with what's on the server or on the remote repository. And you might run into merge problems. Okay. Now, there's also another command that you will probably run into if you're working with Git. That's the fetch command. Now, the fetch command is in essence just a refresh of your remote repository. It doesn't pull the code from your remote repository. It just does a refresh of Git just goes and looks on the remote repository and says, okay, we have these and these and these commands, and then makes it notes it in its local repository. And basically that's just to show you that, well, every time you do that git status command, I think, well, it's going to be up to date now, but if I go to the git demo, I do a git status, you'll see that my branch is up to date with origin master. But that's not entirely correct, because if I do a git log, I don't have the code from the commit from person A, and I don't have that merge commit yet. Okay, but if I do a git fetch, and there you go. If I now do a git status, you'll see that my branch is behind origin master by 2 commits and can be fast forwarded. But if I open up the test.txt, you'll see that it's not integrated with my work yet. It hasn't merged yet. But the only thing that happened is it got all the objects from that remote repository into my local repository. Okay, but it didn't merge them yet. So in essence, if you do a git pull, you're doing actually a fetch and a merge. If you're only doing the fetch, the only thing that you're doing is that you're syncing up the remote repository and the copy of the remote repository, or sorry, the remote branch and the copy of the remote branch in your local repository. If that's too confusing, just forget about the git fetch. It's not that super useful anyway. It has a few useful uses, but those are usually in a CI/CD environment, and you will probably be using git pull anyway. Okay, now the last thing that I want to show you, and that's something that can be useful for you, and that's showing you that Git is distributed and does not always need a server like GitHub to actually collaborate with other people. You can directly interface with other people. Okay, now I won't go into the details about network shares, but let's say that you have, or your colleague has a Git repository on his computer, and you've linked your computer up to his computer using a network share. Okay. What you also can do is git clone, and now let's say that the network share is my C drive. I can clone C temp, and now I can't clone it into my own temp directory because that's the same, but let's give it another name, and I can do that as well. So git clone, and now we will be cloning into the TMP directory, not into the not into the TEMP directory. So this should be a bit familiar. Cloning into TMP, done. So let's go and have a look in our TMP directory, see what happened here. And I have git ignore feature 1, new file, and AH. I have a .git directory. And if I do a git log, I get my merge commit, my code from person A, code from person B, everything. So I now have in my TMP folder a direct link to my remote repository, but using just network shares. That's also possible. So you don't need to work with a GitHub. If I do a git remote -v or -v here, you'll see that I've linked up my origin for this repository is C temp. Right? Now just imagine that this is a network share, which is entirely possible. But if you're doing that on your local computer, that just means that, well, you're working with a local, with local files, but that's just how it is. Okay, good. This should be enough for you to work with remote repositories. I encourage you to experiment with this. Create an account on GitHub if you haven't already, and just see what you can do with this. Clone your own repository into another directory, and then swap directories and work in one directory, then work in the other directory, add, commit, and then push. Okay? Have fun with this, and I hope to see you in the next video series. Goodbye.